Well, welcome everyone. We're excited to be here with you today to talk about building real-time collaborative apps with Azure, Microsoft 365, and the Power Platform. My name is Dan Wahlin. I'm a cloud developer advocate at Microsoft, and I'm excited to have my colleague Ayca with me today as well.
Hi, Dan. Hi, everyone. Welcome to our session. My name is Ayca Bas. I'm a cloud advocate at Microsoft too, and we're super excited to share with you the collaborative app story with Microsoft Cloud. So shall we get started?
Let's jump right in. So from an agenda perspective, we're going to start things off along the lines of what Ayca just said. Like, what do we mean by collaborative apps, and how would that play into your custom apps that you're building at work? From there, we're going to jump into some of the technologies, and we'll introduce the Fluid framework and something called Azure Fluid Relay. Once we get through that, Ayca, we probably need to know when people are available to collaborate, right?
Yes, exactly. And then we will integrate Microsoft Graph change notifications in a new way, not like a traditional way, but we will get a support from other Microsoft Azure technologies too. And we will show you how we use Microsoft Graph change notifications and which data set we use in our app, actually.
Absolutely. So to jump on in here, if you like building, let's say, Lego sets, then this is the session for you, right, Ayca? Because we're going to be putting together a lot of technologies across the overall Microsoft Cloud. So with that, let's jump in and talk about what do we mean by collaborative technologies. So let's say that Ayca and I are working together on an app, and we need to be able to see the data we're changing in real time. You know, Ayca, if you type something or I type something, we want it to synchronize, right? So it all matches up.
Yes, exactly. It's what we do day to day, actually. We use PowerPoint online as well as Word, and we always collaborate in those sort of applications. And that would be nice to have these features available in other custom apps too.
Yeah, and in fact, this slide deck that you're seeing, the images you'll see here, we did collaborate on because Ayca lives in a different part of the world than me. But when it comes to custom type of applications, how do you do that? So let's take the standard to-do list. And let's say Ayca and I are making this to-do list together. And Ayca's typing and I'm typing and we're dragging and dropping. And we could have many other colleagues involved as well. That gets a little bit challenging because what if Ayca types something, then I start to delete it? Well, from an algorithm standpoint, that's actually a pretty tricky challenge to solve. So we're going to talk about that and talk about how we can solve that. So the technologies we're going to start off with first are going to be the Fluid framework. And this is a real-time collaborative technology. This is open source and available up on GitHub. We're also going to be talking about Azure Fluid Relay. And this is a service that's going to go hand in hand with the Fluid framework. And we'll talk you through how those two work together. Now, the app we're going to be demoing here momentarily is also going to have us log in. So we're going to use Azure Active Directory. And then we're going to be using some Microsoft Graph functionality, specifically the Microsoft Graph Toolkit, because it makes it easy to do things like let's get people logged in or out. Let's show the people in a collaborative session through something called a people list. And we can do even more. Now, Ayca, on the real-time presence side of things, what are we going to be covering there?
Yeah, so we will actually do a lot more with Graph other than having the login component and people component. We will use Microsoft Graph change notifications to bring real life people status in our app. So we want to see who is available in our team so we can invite them and they can join us in our collaboration board and we can continue collaborating together. To do that, we will use Power Automate to create and subscribe to our change notifications first. And then instead of using the traditional webhook mechanism, we will use Event Hubs to carry millions of presence status information. And after that, we will use Azure Functions to carry data to SignalR. And then our React app will bring us the notifications right on real time. So this is, I know that a lot of technologies right now, but you will see in our demo app how easy it is and how fluent it works. So then I think it will be really nice to see the demo first, and then we can start talking about the technology.
Now, keep in mind, this is actually an application that is React, but it could be anything. It could be Angular or Vue or just vanilla JavaScript. But this is an application that allows us to collaborate in real time. And you'll notice that Ayca is currently available to collaborate. I got a little toast here. Now she'll talk us through how that works. So I can actually send an invite to Ayca. And what that's going to do is send a message into Teams. And then momentarily, Ayca can then come on in and join us. Now, while she's doing that, let me talk you through what this app does. And it's really just a brainstorm app. Let's assume that Ayca and I are going to be meeting with our team together in a location, and we want to brainstorm on some different ideas that we can use. And there we go. You can see Ayca just joined us there.
I'm in.
All right.
And believe it or not, I receive a notification from Teams, and then I jump in the link.
Perfect. So it worked. That's a good thing. What we can do from here is we can start to collaborate by adding notes. And then you're going to see she'll add notes, I'll add notes, and then we can vote on the notes. And then the top votes will get organized and ordered up here at the top. So let's go ahead and Ayca, let's go ahead and add a few notes as we drag these around. So if Ayca moves the purple note over here around, you'll actually see that and everything gets synchronized. Now we're kind of moving it around. So I'm going to say, let's go. I love to go golfing. I doubt the whole team wants to do that, but that's fun.
Let's think about the team gathering. And I will say that let's have the whiteboard meeting. Okay,
that'd be good. I think I'm going to handle the activities then. So I'll say, let's go to the movies. What else do you want to do?
Maybe bowling. I changed the color.
Bowling's fun. Yeah. Okay. Actually, I really like bowling. It's been a while since I've been. So I'm going to like that. And then, we probably need to get some work done. So I'm going to vote on your whiteboard as well. Now, Ayca can vote.
Movies and whiteboard and bowling.
All right. Excellent. So you can see now that we're able to collaborate in real time. We can type in real time. We can move things. Everything can be tracked in this custom app. And then as we vote on these, and you'll see, like, if I want to take off a vote, I could certainly do that. Down here on the go to movies, you'll notice it showed up. I think Ayca voted on that. But I could certainly change what I want to vote on. I can just click this and get rid of it. But we'll say bowling's pretty good. Now, that's all nice, and that allows us to collaborate in real time. But Ayca, what if you leave, or what if we had other people involved? What would happen there?
Yeah, so what if my machine crashes while we were collaborating with Dan? And sometimes it happens. So let's think that I got offline all of a sudden, and I definitely want Dan to get notified about that. So he will know that I'm not in the board anymore, my machine is crashed, and he will get notification about this too. And all these notification features we build using Microsoft Graph Change Notifications and the Event Hub feature. We will talk next in the presentation.
Excellent. So that's the overall demo. Now, what we're going to do is jump in and talk about the different pieces that we mentioned earlier. And like I've said a couple times, it is an awful like getting a Lego set and putting those Lego bricks together to build this type of a solution, because we need to leverage different services across the Microsoft cloud. So with that, let's go ahead and move on then. And Ayca, let's talk a little bit about the Fluid Framework and Azure Fluid Relay. And this is the real-time collaboration aspect of the application you just saw. So jumping on in, let's assume that Ayca is the client web app. And right now, she's the only one that's collaborating, we'll say. Now, the way this works is the Fluid Framework, as you just saw, is a real-time collaboration framework. That's what it's all about. And it provides fluid data structures. Now, those fluid data structures will communicate down to a service called Azure Fluid Relay. And the service does a few things. First off, it's going to stamp the operations that come in. We call them ops. And it's going to order them. We'll talk about how that works a little bit more in a moment. But it's also going to store information that has come into the service, because if somebody joins the collaboration session later, they would want to be caught up with, where are we in this collaboration session? They'd want to see the same data and things like that. Now, of course, the fluid data structures are nice, but there might be some options there, right, Ayca?
Yeah, so and then before you move forward, what are the fluid data structures?
Yeah, so SharedMap is one of these. And that's the one we're going to focus on in this particular session. But SharedMap is one along with Shared Sequence. There's even some open source options being contributed by other companies coming out, such as a shared tree, for example, where you have a tree structure. You want to collaborate on that. And the list goes on and on and on. You can even do what's called shared string. And that would be where you're typing and Ayca's typing and I'm typing in the same, let's say it's a rich text area. And we could actually type in there just like you would do with something like Word Online or PowerPoint Online, but in our custom apps. Now, if we move forward a little bit, you're probably wondering, well, how does this do it in real time? And the answer is behind the scenes, it is WebSockets. However, I'm going to argue that WebSockets are more real-time messages. We need real-time collaboration because once you start typing and deleting and you get lots of people involved, there's a lot of stepping on toes that happens, and we need to resolve that and use what's called eventual consistency to make sure that everything lines up over time. Now, the way that works is through the Fluid framework. It has some algorithms built in, and if, for instance, I type a message, and that then goes up to the Azure Fluid Relay service, it'll stamp it with an ordering number, as you just saw, in this case, number 1. And then Ayca's client and Lamont's client and whoever's client we have, they would then be responsible for merging that data in the proper order it was received. Now, that's where the algorithms come in. There's a lot to that, actually, that Fluid does for us. I like to think of it as almost like a git merge on each of the clients. It's not a git merge, but you can kind of think of it that way, that data flows in and then it merges it to make sure it lines up properly. So if we type something else, then what'll happen is it'll be stamped like this, you can see, and there we go. We're kind of good to go there. Now we have
That's
number
so
2,
great,
and we can think.
Dan. I have one more question. It's so nice to see that when you type something, Lamont and I receive that right away, real time. But how does Fluid ensure that this information is sent and displayed to the other clients, including, let's say, me and Lamont?
Yeah, excellent question. So behind the scenes, it has a technology called Total Order Broadcast built in. And this Total Order Broadcast is why you see the stamping of the numbers as Azure Fluid Relay gets this. And so what happens there is the service is just what we call a reference implementation. It literally is, there's no code you write. The only code you write is for the clients. That's how that works. All right. Well, to show how this is going to work, we have something called a JavaScript map. Now, we're not going to be using this, but the reason I'm going to show you this is, Ayca, have you ever used a JavaScript map by chance?
Yes, I did, and it looks really familiar.
Yeah, and anybody that's done a key value pair type of structure, this is kind of what you'll see. In the JavaScript world, we could use arrays, of course, but we also have this somewhat newer object called a map. And of course, we can then add a key and a value, and we can call set. And then if we want to get something out, a value, we can say get, and then we can give it the key. Now, a lot of folks watching, you've probably done something like this. Well, what does that have to do with Fluid? Well, remember that Ayca and I talked about something called a shared map. And the shared map is very similar to the JavaScript map. However, it uses the Fluid runtime that runs in all the browsers that are collaborating, and then can send data up to the Azure Fluid Relay service. Now, here's what that looks like. Notice that we get a Fluid shared map. I'll talk more about that first line there in just a moment. From there, we're going to set a key and a value, note 1, hello, and then we're going to get note 1. So we'd get back the word hello, obviously, in this case. Now, that looks an awful lot, Ayca, like what we just saw on the left. And that's what's really, really nice about this is once you know how to do it one way, it's pretty easy to do it the other way. Now, the difference is the JavaScript map stores it just in the browser's memory, whereas the Fluid shared map is able to communicate with the Azure Fluid Relay through a runtime that's installed on the browsers. I need to know, though, Ayca, if you type something or Lamont type something or someone else. So we also have a way to listen for changes. You notice a shared map on value changed, and then we give it a listener function. That's how we can know as data is coming in, and then we can update our UI. So with that, what I'm going to do to wrap this part of the section up is just briefly run you through a little bit of code and show you how all these pieces fit together here. So Ayca, the app we worked on together is, as you mentioned earlier, a React app. And most of the Fluid functionality is in something called the Brainstorm model, and it's a TypeScript file. Now, this is where you're going to see SharedMap is going to be used to send things like when Ayca drags a note or adds a note or types in a note or votes on a note or whatever it may be. All that is sending key value pair data up to the Azure Fluid Relay service. So we'll talk about that in a moment. Now, that's going to allow data to flow in real time from this Brainstorm model, the Fluid, into the, we'll call it the starting page, index.tsx, and then it flows down from there. We have a Brainstorm view, and then the Brainstorm view loads where the notes go. That's called a note space, and then that loads the individual notes. And then finally, we need to hook up to Azure Fluid Relay, so we do have some configuration and utilities behind the scenes that I'll mention real briefly here. So let me jump on over to the editor, and to build this type of app, here is the actual code. So you'll notice that we have right here a area right at the top that is going to be our Brainstorm model, and this is our type, you'll see. So you'll notice that we have a create node and a move node and set node and a lot of different functions we can call. And if I scroll down just a little bit, you're going to notice that here's the function for that. Now we're going to pass something in called a fluid container. We'll talk about that in just a moment. But this is the part I want you to look at. So Ayca, we have this fluid initial objects map, and then we kind of convert it to a shared map, which you'll see shared map right up top there. That's being imported from our Fluid framework package. But where is that coming from? Well, let's jump on over to another file in the project called config and take a look at this object literal right here. Super simple. So the way Fluid works is you have things like a shared map and shared sequence and shared string and others, but they are almost like little Lego blocks, Lego bricks, you could say. And they need to be living in a container. And so what we're doing here is creating a container schema. We give it a name of Brainstorm. And then what are the initial objects in this container? Well, for us, we're just adding a shared map, and there's that shared map import again. And then I'm just going to call the property map in this case. So that's what's happening right here. We're passing that object in. We're saying, all right, let's go to it, go to the initial objects, go to map, and that gets us to that shared map. Now, from here, we can actually use it. I'm going to go ahead and scroll down a bit to a section. So for instance, you saw that Ayca, earlier I mentioned, hey, Ayca, like drag a node around. And she moved it, and then it showed up on my screen. We can do that by calling sharedmap.set. And then we give it a key, and then we're giving it the top and left position from a CSS perspective of the actual note that's going to display in the browser. Now notice when we set a note, we can set the position, the author, the text, and even the color and things like that. And if I scroll on down, you'll see not only can we set, but we can also get. So there's a lot we can do here with just a shared map to send a key value pair. Now, every time we do this, that's going to send an operation up to Azure Fluid Relay. It'll order it. That's the total order broadcast. Push that out to all the clients. And then eventually we will all be consistent in our collaboration session. Now, the other little piece I want to show you here is related to this configuration. We also need to connect up to Azure Fluid Relay and do those type of things. Well, we have a little bit more code here. We have get fluid container. And then the only line I really want to show you first is this one. So at the top, you're going to notice another import for Azure Client. And this is from Fluid Framework Azure Client. Okay, so that's in my package JSON. Let me scroll on back down now. And what we're going to have here then is the need to hook up to the service I talked about. So we have a new Azure client. And then from here, we're either going to use that to create a new container, or we're going to get a container. And remember in the slides earlier, I mentioned that there's a little storage. So maybe Ayca and I already had a collaboration session, and Ayca, you join, tomorrow, and you want to get right back where we were. Well, in that case, we would get a container. But if we're starting a new session, we could create a container. Now, the container schema you have here to kind of wrap this part up, that's actually what we have here. There's our container schema we just looked at. So pretty straightforward, standard JavaScript, TypeScript type code. Now, once we've created the container and we've hooked that up to the Azure Fluid Relay, then we can start to use it. Now, you've already seen the set and the get calls, but the final thing I want to show you is we can also know when things change. I can know when Ayca adds something, or Lamont, or whoever's in our collaboration session. Now, to do that, in the Brainstorm model at the very bottom, you're going to notice I have a set change listener. And that just allows us to pass in a change listener function. We're going to say, all right, when the SharedMap value change fires, call that function. Now, we're using that right here. So let's say Ayca added a note. Well, what will happen is we're going to call that set change listener. Ayca adds a note on her machine. That op goes up to Azure Fluid Relay, pushes it out to me. I will then get notified, and notice that calls this sync local and fluid state function. That's this one. Now, what this does is just basically loops through the data that we have locally and what we received, what's been updated that Ayca sent, and then it just re-renders the UI. And in this case, it's React. We're using React use effect, but again, you could do this in Angular and Vue and just plain JavaScript. So that's a quick run through of what we can do to get started with this. And that covers our real-time collaboration section. Now, Ayca, I know you have a lot more goodness to share with us today about how we can actually do more than just this demo, and we can actually integrate with real-time graph notifications. Let's talk about that a little bit.
Yes, definitely. Now we saw how we can build our notepad that we collaborated with Dan, and we use Fluid framework on that, which is super cool. And you also see in our little demo, we have notifications coming whenever someone is available, or when someone is offline or out of office, and so on. And that's where we use real-time presence. And we use another method of getting the data real-time, and we leverage from Microsoft Graph Change Notifications. Let me quickly walk you through what are Microsoft Graph Change Notifications. Firstly, Microsoft Graph is an API for us to connect with Microsoft 365 cloud datasets. I'm sure, Dan, you used Microsoft 365 datasets before. What are your favorites?
Well, this is probably one of my favorites because you and I do a lot with this real-time collaboration these days. But there's all kinds of services you can tie into. So, for instance, a new user has been added to the overall system. We could be notified about that. And you could use that to automate a lot of processes. But as you show here, there's a lot more we could do, right?
Yeah, totally. And I'm sure if you know Graph, if any of our developer audience know Graph, maybe they heard Graph Change Notifications before. These are actually using webhook mechanisms to deliver the notifications to the clients. There's a traditional way that you can use the webhook mechanism, but also let's think about a scenario where maybe Dan and I are trying to get all the presence status from Microsoft people. Whoever is the Microsoft employee, we will track the presence information. Can you imagine how much data we can collect in a day, even in an hour? Do you have any guess then how much presence status we can collect?
Well, within Microsoft, I'm sure it's millions. Hard to say, but it would depend on the company, but lots. Let's just say lots.
Yes, exactly. I mean, if we track all this data coming through, and if we use the traditional webhook mechanism, it might be challenging for us to process all these millions of data. Instead of that, we actually use the new way, which is the integrated way with Microsoft Azure. We use Event Hubs for collecting all the data from Microsoft Graph Change Notifications. Event Hubs is the product which can handle millions of data in a second. And it helps us a lot in this scenario where we have high throughput or where we are handling bigger data sets, or if you have multi-tenant projects going on, if you want to collect a lot more data, presence data real time, then Event Hubs is definitely helping in those sort of scenarios. Let me quickly walk you through how we build the presence changes real time. So basically, first of all, to use Event Hubs together, Microsoft Graph change notifications, we will need Event Hubs first, and then we will need Key Vault. After we create Event Hubs and the Key Vault, we basically start tracking, we need to start tracking the changes. There are different ways of doing that. Mainly, we have to subscribe to the change notifications, and then we will start getting the information. Either you can call the Graph Change Notifications API on your code, or in our case, we use Power Automate to create the subscription and then renew at the top of the hour. It's easier for us because we don't have to write any additional code, plus it automatically renews the subscription, which is an amazing feature for us. And after we subscribe to Microsoft Graph change notifications, whenever there's a change, we want to receive this change in the event hubs. To do that, we actually need Key Vault, because while we are basically subscribing to the notification URL will be in the Key Vault. And we keep Event Hub connection string in the Key Vault just because of the security reasons. I'm sure then you used Key Vault before in the same purpose.
Yeah, it's great for any of those secrets you don't want to get out there, especially not in your source code. And you want to store them somewhere safe, and Key Vault's great at that. Yeah.
Yeah. So if you check out Microsoft Graph change notifications, you will see that there will be a notification URL we have to define. Instead of using any webhook, now we're going to define notification URL as our Event Hub URL. So to do that, you will see at the bottom it's saying Event Hub HTTPS, and it's going to be the Key Vault name. We basically use Key Vault URL to connect with our Event House because of the security reasons. And then we just share the secret name, which has our connection string. And after, it's just the domain name, our tenant ID, and we're good to go. Whenever there's a change happening, in our case, it's the presence information, we will receive that data in our Event Hubs. Next, how are we going to bring this data from Event Hub to our web application? So now we understood how we can build this Event Hub functionality with change notifications. Our next step is to connect with our web app. To do that, we create Azure Function apps, and we define input as Event Hubs. So whenever a message comes, we will direct to Azure Function apps. And after that, we will define SignalR as an output. So we will direct Event Hub messages to the SignalR, and SignalR will broadcast the messages right away to our web app. Okay, so I did exactly the same thing to walk you through how we built this entire thing in the blog, just like in our code, just like Dan did. And in my case, as you know, everything starts with index TSX, and when we run the app, index TSX starts running, and after that, it automatically brings everything on the page. And after that, when we run the app itself, we will also call SignalR connection TSX, which is running the SignalR, and we start listening what is happening in the background in the SignalR. When there's a new notification, basically there's a new message in the Event Hubs, then we will receive that information from the SignalR connection TSX, and it will direct us to Graph Notifications TSX, where we build our notification pop-up notifications, and then this will appear on our screen by just calling the notification function in the Graph Notifications TSX. So once we have the little pop-ups notifications on our screen, as you saw, then click the button to invite me through Teams. And we have another function inside the same Graph Notifications TSX. Once he clicks and invites me, we need to send a URL to the person through Teams. Then once someone clicks, we will call graph chat function, which calls Microsoft Graph Teams API chat functionality, and then sends me a URL, and then I click and join the same environment, and then we start collaborating. So how to build this entire thing? I will just walk you through our code. It's exactly the same code that Dan shared. I will just show you how we build the presence information. I'm in the index.tsx here, as you can see, and everything starts in index.tsx, as I mentioned. At the bottom, you see that when we first run the app, we call SignalR connection. And SignalR connection is actually the file here in SignalR connection TSX. We automatically call this function a SignalR connection function. That means that we are connected to our SignalR. And as you know, the way we do that is through Azure Functions. As I mentioned before, we define Event Hubs as input and SignalR as an output. Before we jump into this part, I just want to show you how we build our functions. You can do this part on Azure portal, or you can just write the local code to test out your functions. On the left side, under the Event Hubs functions, you will see two different folders. One is negotiate and another one is broadcast. Let's quickly take a look at the negotiate part. Negotiate is actually for our negotiation with SignalR before we authenticate and connect with SignalR. This function only keeps SignalR connection information, which is the connection string. So once we get the connection string from SignalR, here you see the only thing we have here is the connection information from SignalR, then we're good to go with connecting with our event hubs. Under the broadcast, let's go to function JSON, and you see here under the bindings, we have event hub messages as input, and we have SignalR messages. It's important to define this as serverless as output. That means whenever new messages coming from event hubs, we will direct it to SignalR messages. Let's take a look at the index.js. Here, as you see, for each event hub messages, we run this and we actually send the exact information from Microsoft Graph. And here I actually refine the data. Instead of sending the huge JSON file to our app, I just refine the information, and whichever information we need, in our case, it's ID and availability, I just send this data to our app. So it's not going to be a huge information, and we don't have to write any other code. And once we send the SignalR messages, the rest is just through our app. As you see, we are already connected our SignalR connection here. And when we receive a new message under the SignalR connection TSX, we call the notification function, which is under the graph notifications. Let's quickly go to the definition. We are in the graph notifications TSX, and here we have the notification function. The basic thing we do here, first of all, we check if user availability we are receiving is status available, because we don't want to receive all different sort of status, like let's say if I'm do not disturb, or if I'm not available, basically busy, I don't want them to be notified about that, because obviously I'm not available to collaborate. Once the user availability is available, and if it is user which is not logged into our Brainstorm app, then we basically send the person card. It is, again, Microsoft Graph Toolkit person component. And here we send an information about person user ID, and we also send show presence. We show the presence in the same card, and plus we have the button to invite that person if that person is available. And as you see, when Dan clicks on that button, we call our graph chat function, and I'm going to talk about that in a minute. But also at the end of our demo, you saw that we also get notification if someone is logged in, but let's say their machine crashed or they're pulled into something else and their status changed all of a sudden. We also want to inform our collaborators in the Brainstorm app so that we check if user ID is the logged in user, basically a logged in user status changes, we want to again send the person component and notify the others who are in the Brainstorm app. And the last thing I want to talk about is when Dan clicks on inviting me to the conversation, we directly go to the graph chat function. And here we call Microsoft Graph Teams Chat API. So we can send whichever URL we want to send to our users. In our case, Dan sent me the Fluid Framework URL, and then I click on the Brainstorm URL, and I joined the Brainstorm session with Dan, and we started collaborating. And this is basically all how we created the presence status changes in real time. If you are interested in building exactly the same application, we actually have the GitHub repo with you to share. Let us quickly go to resources. Dan, would you like to talk about the resources?
Sure. So as Ayca just mentioned, the Brainstorm app code, you can find that up on GitHub. So feel free to clone that or download the zip or whatever you want so you can get to that code. The Fluid Framework part that we talked through a little bit earlier. So if you go to fluidframework.com, you can learn about SharedMap and shared sequence and shared string and how all that works to connect up to Azure Fluid Relay. You'll see a link for that as well. And then everything Ayca just covered, you can learn about that in the Graph Event Hub section there. And then we also have two scenarios we wrote up, Ayca. You want to talk through those real quick and what they offer?
Yes, exactly. We have two great scenarios available in Azure Architecture Center. These are actually exactly the same thing. If you go to GitHub, you will see our app. But if you want to also deep dive into architecture and how we consume this solution, what are the use cases, you can check out our scenarios on Azure Architecture Center and understand what technologies are used. Also, what is the scenario behind it? Basically, more information about Brainstorm app. It's divided into two pieces. The first piece is talking about the Fluid Framework and everything Dan covered, and the second piece is talking about the real-time presence, and we talk about Microsoft Graph change notifications on that part. And with that, I think we are done with our session. Thank you, everyone, for joining our session. I hope you find something useful, and I hope you enjoyed our presentation.
Thanks, everybody. We appreciate you taking a look at this. And there's a lot of great stuff with real-time collaboration you can add to your app. So take advantage of it and try it out.